Okay, something else you'll be asked to be able to do is to how to plot parabolas. So you can sketch them, you're also asked to be able to plot them. Being able to plot them provides you with information of y values, or values of y, for each value of x. And it's a nice way of seeing what happens to a graph, or what happens to an equation, depending on what you have going in. So first thing we're going to do is we're going to have a look at x minus 5 all squared plus 1 over a domain of 0 to 6. So that's where you set up your table, your x values of 0 out 6. So 0, 1, 2, 3, 4, 5, and 6. There are possible x values. And what we do is we substitute each of these values into the equation, and then we come out with a y value. So let's see. So now at x equals 0, we're going to have negative 5 squared plus 1. So we're going to end up with 26. I'm going to do this in blue actually. 26. So at an x value of 1, we're going to end up with negative 4 squared plus 1, so we're going to end up with 17. At 2, we're going to end up with negative 3 squared plus 1, so we're going to end up with 10. At 3, we're going to end up with negative 2 squared plus 1, so we're going to have 5. At 4, we're going to have negative 1 squared plus 1, so we'll end up with 2. At 5, we're going to end up with 0 squared plus 1, so we're going to have 1. And then at 6, we're going to end up with 1 squared plus 1, so we're going to end up at 2 again. So now, based on that, what we can do, we can see that our values start high, they decrease. As our x values increase, our values decrease, and then they start to increase again. So what we're saying here is from 0 out to 5 we're decreasing, and then from 5 onwards we're increasing. So what we can do there, we can say that if we've got an axis of symmetry, so where our turning point is, that's where our values reach their minimum value. So here that happens at 5. So our axis of symmetry is the equation x equals 5. So if we have a look, 1, 2, 3, 4, 5, 6, we are going to have an axis of symmetry here at x equals 5, and that's how we draw it. It's a vertical line at 5. So that's our axis of symmetry. Now at 5, we've got a y coordinate of 1. So now we've got a turning point at 5 and 1. So I'm going to put a dot here for 5 and 1. And that's what we've got going on there. To state our y-intercept, we know that our y-intercept happens at x equals 0. So we have a look at x equals 0, and we see it's 26. So our y-intercept is 0 and 26. Now, all of this helps us to sketch. So at 0 and 26, we're going to be up here. At 1 and 17, we're down to about here. At 2 and 10, 3 and 5, 4 and 2, 5 and 1, and then 6 and 2. So our graph will go through each of these points like so. And then from there, we could have any number of different questions asked of us, like, for example, what is the maximum height it reaches? Also, based on this, because our values reach a minimum value, we know we've got a minimum turning point. So that's one thing we could be asked, whether the turning point is a maximum or a minimum. We could be asked to find a y value for an x value. We could be asked to find an x value if we're given a y value. We could be asked how the difference in heights between two values. Any number of different things, but it all comes from interpreting the table and make sure that our graph lines up with the table that we've drawn.